Euclid's Elements, Book 3, Proposition 24. Similar segments of circles on equal straight lines are equal to one another. So in Prop 23, we had two similar segments trying to be constructed on the same line. Now we're going to construct two similar segments on equal straight lines. So let's have segment ACB. And let's have another segment, a similar segment, constructed on an equal straight line. So we'll have CD and we'll have CED. So it's given that this segment ACB is similar, there's this word, is similar to segment CED. And what we're going to prove is that when we apply ACB to CED, it's going to perfectly coincide in every respect. And if it coincides, then it's going to be equal. So I say that these will be equal because they will coincide. So the first thing we're going to do is we're going to apply this circle segment to this circle segment. Let's start by applying line AB to CD. Well, we know that they're equal. Okay, that's a given. So if we put point A on point C and lay AB along CD, point B will line up perfectly with CD. So AB will perfectly coincide with CD because they are the exact same length. Then the question is what will happen to ACB? And there's only four possibilities that the curved part, ACB, it will fall in one of four ways. It will either fall above this segment, below this curve, it will fall above and below at the same time, which is, we'll call that a rye, or finally it will perfectly coincide, it will fall on it. And what we're going to show is that it will not do any of these first three things, therefore it must do this fourth thing and perfectly coincide. So what we're going to say is when we apply C on here, C is either going to be below, like this, or C is going to be above, like this, or perhaps C will be both below and above at different times. Maybe it will fall like this. Below here, and then above here, and then back to finally coincide here with D. And that's the situation that we call falling awry. So let's look at these possibilities. Can it fall above or below? We've already looked at Proposition 23. Proposition 23 of Book 3 says that if it falls above or below, it creates a contradiction where the external angle is, so we'll just do this really fast. This is just a basic repeat. If C falls up here, then we can run a line like this, and because they're similar segments, these have to be the same angles. That's what a similar segment is. It admits at the same angle. But this is an exterior angle, so these are both equal, but this is also greater than this. This is equal to this and greater than this. That's the contradiction of Prop 23. So it can't fall, C can't fall above or below E. So this is ruled out, this is ruled out. Well, as we said before, what if C falls kind of below it at first and then above it after that? So what if C falls like this? So here's E, there's C. What impossibility occurs there? Well, according to Book 3, Proposition 10, as you can see here, I'll just mark the places where these circles are cutting each other. But here is a place, right here, they're cutting, here they're cutting, and right here they're cutting again. So you have two circles that are cutting in more than two places. And this Proposition 10 says circles can never cut each other in places more than two. So we have three cuts, which is an impossibility. Therefore, it can't fall weirdly like this. It can't fall awry. Well, if it can't fall above, below, or awry, the only other way it can fall it can perfectly coincide. And that's what happens. C is going to perfectly coincide with E, and it's going to lay right on top of it. And if it perfectly coincides, then it is equal. And that's what we're proving. So if we have similar segments of circles on equal straight lines, they perfectly coincide and therefore are equal. Thus we can conclude with QED.